Okay, looking at combinations now. So there's, again, combinations versus permutations. Combinations is our other sort of type of probability event here. There are two types of combinations. Combinations order does not matter. Again, repetition is allowed or there's no repetition. So combinations with repetition says these are hardest to explain, so we'll come back to these later. Let's go combinations without repetition. So this is how lotteries work. Numbers are drawn one at a time, and we have the lucky numbers no matter what order we win. So easiest way to explain it is to assume that the order does matter, then alter it so the order does not matter. Going back to our pool ball example, let's say we just want to know which 3 pool balls are chosen, not the order. We know that 3 out of 16 give us that many combinations, but many of those are the same to us now because we don't care what order. For example, let us say balls 1, 2, 3 are chosen. These are the possibilities. Okay, order does matter, order doesn't matter. So what it's saying is you just have 16 balls. It does not matter which ones it is. Okay, it doesn't matter if it's the 8 ball or the 7 ball. All that matters is that you are choosing 3 of them. So, in fact, there's an easy way to work out how many ways 1, 2, 3 could be placed in order. We've already talked about it. It's factorial. Okay, 3 factorial. So 1, 2, 3, as you can tell, are organized, started on the previous page. Oop. Down here, the first one, right? 1, 2, 3. And then 1, 3, 2, 2, 1, 3, 2, 3, 1. There's 6 ways to order 3 different numbers. Those are your different types of combinations that you can get. For another example of 4 things placed in 4 factorials, 24 different ways. Okay, so we adjust our permutations formula to reduce it. Is how many ways objects could be. The formula is so important, we often just write the big parentheses like this. So it's n factorial divided by r factorial, parentheses n minus factorial, but this is also known as n choose r. Okay, often called n choose r. So one thing that we can do on our calculators, okay, is under that math, over to probability of NCR, the third option, right? That's n choose r. Okay, so on the next page here, it shows that example. It gives the different formats of it. Okay, n choose r, NCR. Without repetitions, we have NPRs are permutations, NCRs are combinations. So that's where both of those are coming into play. It goes through and talks about some different examples here. So now our pool balls without order, 16, it gives you that equation there, 560 different ways. Okay, I don't need to go through the math. You guys see that math there. It is interesting to also note how this formula is nice and symmetrical. In other words, choosing 3 balls out of 16 or choosing 13 balls out of 16 have the same number of combinations. It's kind of neat. All right, it's kind of neat. Obviously, as the numbers increase, so will your options. So, something there to think about. It then talks into Pascal's triangle. We don't have to go into this explanation. It's just a very cool mathematical phenomenon of how things work. If you have any interest in time and you want to research Pascal's triangle, go for it. It is kind of cool. And something you'll explain in college, or something you'll dive into in college if you dive into deep math. Combinations with repetition. Okay, so if we tackle this one, let's say there are 5 flavors of ice cream: banana, chocolate, lemon, strawberry, and vanilla. We have 3 scoops. How many variations are there? So the letters talk banana, chocolate, lemon, strawberry, and vanilla. Examples, you'd have chocolate, 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 or banana, lemon, or vanilla, so on and so forth. There are 5 items to choose from, and we choose 3. Order does not matter, and we can repeat. Now, it says I can't describe how to calculate this, but I can show you a special technique that lets you work it out. So I'm not going to really focus in here on this details here. What I'm going to go show you the equation, because that's what the most important thing here is. So instead of worrying about the different flavors, how many different ways can we arrange arrows and circles? They talk about arrows and circles instead of the flavors. here is an equation that lets you figure this out. So you have r, which is your number of choices, n, which is your number of options, r plus n minus 1, all over r factorial n minus 1. Okay, we don't do a ton of these problems. Don't do a ton of these problems, but it is important to have the information there available to you with your equations. Okay, so if I'm just looking at our permutations and combinations worksheet here, evaluate each permutation combination. You must show that setup. So what they're saying here is, and this one is pretty straightforward. You know, if you go to your calculator, we're doing NPR. So now you got to make sure that you type in your numbers in the correct order. So I'm going to go 7, math probability, NPR 3. Okay, and that is 210. All right, 7, choose 3, it gives you 210. If we look at, say, number 4, 8C3, we're going to go 8, combination 8C, 8C3, and it gives you 56. So a lot of the math is going to be done for you. It just depends on how many you are talking about. And you also have to understand, are you talking permutations or combinations? Okay, permutations or combinations. So there you go. And like I mentioned earlier, let me know what questions you have. Thank you.